Grant Young, everyone.
And I'm going to co-opt a little bit of your talk as well. I wanted to start tonight by also acknowledging the traditional custodians of the land on which we meet, the Gadigal people of the Eora Nation, and pay my respects to their elders past and present. And one of the things I want to do is to acknowledge that Australia's first people are innovative peoples who have been innovating on this continent for over 40,000 years in one of the most, well, perhaps one of the most inhospitable environments. And I think we can learn a lot from the perspectives that they bring to some of the challenges that Western ways of thinking that we're grappling with. In terms of thinking in multiple generations, in thinking about the idea of the long now. How many people have heard that term before? So there's a few people. The idea of thinking in 10,000 year clocks instead of, a couple of year clocks. And I think that we can learn a lot from Aboriginal science in particular as we start to address some of those challenges. And as you're probably aware, Indigenous peoples around the world typically have a very strong connection to country. And I don't know about you, but my time living in Sydney couldn't be kind of further from that experience of being connected to country. And so that's partly what I'm going to be talking about this evening, is how might digital technologies, ironically enough, bring us a little bit closer to the idea of connection to nature, and how we can learn from nature in terms of our built environment and using technology within those built environments as a way of actually connecting to some of the things and challenges that we face. And part of the reason why I think personally why I think that's important is because the UN estimates that 54% of the world's population currently lives in urban areas. And that's expected to rise by 2050 to be about 66%. So we're increasingly becoming embedded within city environments in particular, and especially large cities like Sydney. And City of Sydney Council in particular has done a little bit of estimating of their own that suggests that by 2030, 80% of residents within the city will live in apartments, and 90% of all new dwellings will be high-rise. So if we think about our city at the moment, I did look up the stats. I think there's about 200,000 people currently in the City of Sydney, and a majority of them are in high-rise or high-density living arrangements. For me, I come from a background that crosses technology, user experience and sustainability. This is a really interesting problem space, and I'm really intrigued by the parallel diamonds, because I think you might see a little bit of that at work here. I really like it as a model to kind of describe what we're doing in thinking about this particular problem. One of the challenges with this, though, is that apartment living, if we have a look at the stats, apartments typically per person or per resident, some estimates say are 84% more greenhouse gas emissions than a typical residence or standalone residence. Now that may come as a surprise to some people, myself included, who used to live in an apartment thinking my footprint was small. My carbon footprint, my environmental footprint, that isn't city living meant to actually reduce that. So problem worth solving is kind of the message here. What could we potentially do about that, and how might we start to learn about that? One of the things that drives that inefficiency is that common area equipment, things like heating pools, running lifts, air conditioning systems and things like that, which are at the building level, contribute to a lot of that. But over 30% of a building's emissions come from what happens, what I like to refer to as within the walls within an apartment. It's a much harder problem to solve because you're not dealing with a central committee that can make decisions. You're dealing with a lot of individual residents. And I think that as the low-hanging fruit of building management starts, because there's obvious cost savings that can happen, start to get dealt with, that we're going to need to start thinking about behaviours within apartments and how we might change that. So it's an interesting problem space. And that kind of begged to me, I don't know how many people are familiar with the how might we question? Yeah, so it's cool. So it's a particular way of framing a question that I believe the IDEO are kind of often credited with this particular type of question. And it begged for me a question, how might we address the barriers to achieve energy efficiency in high density residential environments? So that was a starting point for inquiry, I suppose, in thinking about that. Being a kind of design person, I started to dive into that and look at that from a number of different angles. But that gives you a bit of a sense of the problem space. There are some particular challenges with the high density residential that started to emerge as we started to think about that particular question. One of them is the fact that most of the existing solutions that kind of drive behaviour change, that monitor energy, for example, rely on access to the meter. How many people here live in apartments? Okay, so quite a few. How many of you, can you keep your hands up? How many of you, so put your hands down if you don't have access to your meter, or you don't know if you have access to your meter. Okay, so a few people have got it, but we've lost at least half of the people. Now, if you had to put a device on that meter, do you think you would have permission to do that, those that still had their hands up? Okay, so one. I'm intrigued by your...
I'm just guessing.
It's a hypothesis. It's a hypothesis. Great question. That's right. So we can see even if you did, it's still very, very few people. So existing solutions aren't necessarily going to translate into this particular context, but that's just one problem. If you get access, you need to have power at the device. You need to have that device within range of a Wi-Fi or 3G network. You need to have potentially approval or the skills to be able, and confidence to be able to install it, or you're going to have to pay somebody to do that. Right, so we suddenly start to see that, probably at the end of that, there's going to be very, very few, if any, people that can actually act on that. So it kind of begged another question for me, being how might we measure energy consumption within apartments without relying on infrastructure and external factors? So that was the question, and these questions are all bubbling along. We haven't answered any of these, but we're starting to get, and if we have a look at the lean canvas, which underlies a lot of these questions, I'm not showing it tonight, these are the sorts of problem statements and things that and assumptions and hypotheses that we're testing as well, coming into that. Another part of the challenge is that the personal or individual economic benefit doesn't stack up. So what I mean by that is a lot of energy efficiency programs or devices, for example, suggest that you can save money by being more energy efficient in an apartment complex. And I mentioned a stat before that over 80% or 84% of high-rise higher emissions, 84%. Individual apartment expense on energy is about 60 to 70% that of a typical residential dwelling. So the individual apartment at that level, you're not saving a huge amount of money, you're not spending a huge amount of money on your energy bills, okay? If we have a look at a particular example that was in The Guardian just the other day, Power Shop, great power company, B Corp, I like them a lot. They did this kind of promotion looking at energy efficiency. One of the things that we think about is the cost of making changes to actually be more energy efficient is actually quite high in terms of the energy expense. So if we hone in on one particular example, they kind of break this down. Hot water isn't listed on this, and I think that that's rather fortuitous because most people in apartments can't change their hot water service either, but it's a big expense. So again, you can't change your hot water, that's one thing. If we have a look specifically at the fridge, your fridge typically costs you about $150 a year. Now, last time I checked, which has been a while, a fridge was about $750. Maybe you can get them a little bit cheaper. But if we assume a 10% efficiency gain by changing our fridge, that means we're saving $15 a year. $750 for a fridge, $15, it doesn't stack up. So I'm not going to go and change my fridge unless my fridge needs changing for other reasons. So there's a limited ability to be able to change things, right? So these are some of the challenges that come up. And the last point is that if you look at the devices that are currently on the market that don't rely on access to the meter, they're actually quite expensive. So just a really rough cost, 1 year's electricity cost for an oven, for one power point to monitor its energy consumption, be able to turn it on and off automatically, potentially from your phone. So that return on investment mentality that's often used, for me, just doesn't quite stack up. So we're going to have to rely on different ways of doing that. So what might we do to deliver a compelling value proposition, coming back to the value proposition canvas, that beyond a direct return on investment. So we need to start thinking about what that might look like. And part of that might be rethinking the idea of customer, but we don't have enough time to go into that tonight. This is the other problem. If you do a quick search for energy monitoring, pretty much all of the existing products look like this. Are we noticing a trend? Dashboard, graphs, charts. I don't know about you, but that doesn't necessarily speak to me all that much. And research shows that it doesn't speak to a good portion of the population, particularly a lot of the people that are actually consuming the energy within a household. one of the things that I wanted to highlight is some great research by a researcher out of RMIT, Yolandi Strengers, who proposes that she's done a lot of work observing home energy with smart home meters and this in the domestic environment. And she posits that the idea or the vision of the smart home and the smart city could be summarised in this idea of resource man. And I just wanted to quote, the reason I'm looking at my notes is I wanted to quote from an article she did in Interactions magazine. Resource man embodies a unified vision for the smart energy consumer. He is an efficient micro-resource manager or a mini-me version of his utility provider. And I kind of emphasise that. Continuing to quote, I refer to resource man as a male, not because he's always directly identified as one, but because he is cast in the image of the male-dominated industries of engineering and economics that permeate energy management. Moreover, visions of him exclude much of the productive work of the home, which is still carried out by women. So there are other issues with the resource man framing that I don't dive to delve into, but I think fundamentally we can see, if we look at the trends of those screenshots before, but also this research, is that it begs another question of how might we engage people other than resource man in ways that positively influence their consumption behaviours. So just to talk into energy theory, just very, very briefly, energy behaviours is not just about reducing consumption. It's also about moving consumption patterns to different times of day, because that drives a lot of the cost of the electricity networks and therefore the costs of bills and things like that. So there's a lot of interest with power companies in particular to do what they call load shifting, which is to move things to different times of day. So can we use this technology not just necessarily to reduce things with this return on investment model, but how do we do that? So I've probably spent too much time on the problem. I'm going to jump into some inspiration points. So thinking about those problem spaces, I thought surely people have started to think about this before, right? Yolandi's work is one example of people that have been doing a lot more thinking than I have. And so what else might exist out there? So I just wanted to share some examples of what I've kind of found in doing that quick search. One example is from the Artifact group. It's called the Serenity Home Operating System. And this is just one of the screenshots from, or a photo press shot from what I believe is a design concept. It's a little bit unclear as to whether this was ever intended to be a product, but I believe it's just a design concept. And what it does is take that typical interface that we see of an in-home display that shows those bars and graphs, but instead of bars and graphs, we actually now see some things like leaves floating in that particular interface. So it's just a nicer version, but it's actually taking one step away from that idea of the bars and graphs. As the name might infer, it's not just about sustainability. So it's thermal comfort, so that, you know, like Nest, getting into your heating and cooling, air quality and home automation, and even music control. So for those like me that love a minimalist interface, this is really a beautiful piece of work. But the key thing around that is that the value proposition is not about energy management per se, but it's a part of a bigger picture and a system that would otherwise have value. So therefore the value proposition is not just around the environment. If we take that idea and then start to build that into a device instead of just a screen, we end up with a couple of different systems that look a little bit like this. This is the Watson, which is from a now defunct business called Do It Yourself Kyoto, or DIY Kyoto. And if we, on what would be your left, it uses the traditional kind of display of numbers and figures showing your energy consumption in real time and how much it's costing you. But then underneath, you also see this idea of an ambient interface that's actually just using LEDs to give you a sense of how much energy you're using at any particular point in time. Taking that another step further, this is another example, a Kickstarter campaign that was successful but is no longer continuing. There's a theme here. Some of these aren't continuing. Maybe not the best business proposition. But it uses gestures. This is the Ninja Sphere, and it uses gestures, and again, it's like the Serenity Home Operating System in that it's a home automation system that included energy monitoring and being able to turn off devices on and off in doing that. I really like those because it starts to embody in a different type of interface, some of these ideas. But what if we were to look at the communal level, but also start to rethink the whole idea of what interface means? And so this is another example from Helsinki. It's called Nuage Vert, if I'm pronouncing it correctly. And it's described as a city-scale light installation. So this actually happened where they laser projected this green cloud on top of the nearby coal power station steam cloud. So for those that aren't familiar with coal power, the smoke coming out of it's not smoke from the coal, it's actually the steam from the turbines and generators. And if the local community was using less energy, the green cloud would be bigger, because therefore you're doing better, bigger is better. I don't quite understand why they didn't make it smaller personally. I think that's one of the interesting things. I'd love to know the design rationale, because I'm sure there's really solid reasons behind it. Maybe there isn't. Conversely, it would be smaller if they were doing less. So this is taking the idea of interface, I think, quite to extraordinary lengths. But there's an example later that starts to bring the two worlds together, maybe to a more human scale or a smaller scale, how you might do that communal work. Bringing that into the home, this is an example from Static, and I've got two examples from that, which is an exhibition that was looking at different ways of displaying energy usage. And it's a great way, I think, of the principle of making the invisible visible. So the cable on the power cord glows brighter the more energy that's used. So we're now getting far away from this idea of specific numbers and graphs. But if I'm turning that kettle on, knowing the rough power consumption of a kettle, that thing would be going very bright quite often, and you'd start to rethink maybe doing that. It's the principle behind it. Again, design concepts. I really love this example, though, from the same exhibition, same group. This is called the flower lamp. And essentially, this is the two states of the lamp. On your left, the lamp is in full bloom. This is when it hasn't been used much. And it uses heat memory alloy that, as it's used and it heats up, it actually wilts, like a flower would if it was too hot. And so another beautiful example within product design of an ambient style interface that uses that. And it uses a principle called biomimicry. Has anyone heard of biomimicry before? So quite a few people. Great. So it's taking inspiration from nature and then applying it in the products that we design. This is an example of it at the product level, but that principle can be applied also at the systems level. And I'm not going to be able to do this justice with the short video, but there's a great, this video is available online as part of the Biomimicry Challenge. It's from Smart Design. And they basically looked at how they could take the biofeedback systems that we see in nature and how might we apply those in an urban environment. So it's things like pulsing water that demonstrates how many bottles of water you're using when you're running a tap. It uses, in the next example, which we won't see, it puts a display in the lift that shows the building's water consumption. And it's very specific. This particular example is very specifically focused on water, but I think a lot of the principles would apply. So that was a real whirlwind tour through a whole bunch of ideas around biomimicry and things like that. Can't go into. But what I find really inspiring about all of these, has anyone heard the idea of a minimum viable product? Yeah? Viable is a word that often makes designers cringe. I'm one of those. What I really like that seems to be emerging within the lean startup community is the idea of a minimum delightful product. Now, it's not about doing or lovable product, yeah, it's another one. So this diagram, I think, is fantastic to demonstrate what I think is the difference. Rather than just looking for the functional thing that works, you're looking at what's the minimum that you can do to give that sense of delight with the customer or the end user of the product in order to be able to do that. And I think that's at play in all of those examples that I just put forward. And I really like that idea. So I started to think about, well, what could we actually do with that? And so, brainstorming from existing ideas, we thought, what if there was a digital pot plant like the flower lamp that had leaves for the health of your house? And each of those leaves might be air quality, water usage, etc. What if they were to wilt and give you a demonstration in real time of what's happening within your house? Or another kind of example building on that kind of basic idea is, how many people can remember Tamagotchis? Yeah, old enough to remember that. I'm not talking so much about the form factor of a Tamagotchi, but thinking about what would the Tamagotchi for your house or representing your house look like? Jarvis. Like who? Jarvis? Maybe. So one of the things about the idea of this that I wanted to kind of jump into is not so much about the aesthetics, but thinking about the sorts of interactions that these devices demanded. And I use the word deliberately, demanded, because it was about keeping your digital avatar alive. What if we applied that in the idea of energy consumption, where you had to take action in order for your house to be healthy, or your digital avatar there? So it requires action and engages gameplay. It has the potential to engage kids, which through previous research, when I was working with WWF, we identified that kids were actually a really important information passer-oner to parents and behaviour changer for parents. So in two ways. One, parents were looking for things that they could engage their kids with, and the second thing is the kids were bringing things home from home and they were learning through that process as well. We can also start to think about how might that be connected to social engagement across devices and with other people in your block, in your community. It also speaks, I think, to building a sense of character into the device. And this is a device that uses open source hardware, which is a running theme, an Arduino-based lamp that was also on Kickstarter, that I think has a really strong sense of character. You can just kind of see, and it exudes that character. It's promoted that way. What I like about this idea of character, and there's some recent dialogue, Ben pointed me to a great article that was looking at the Amazon, is it the Echo? Is that what? And the Google product. Google's product doesn't have a name, but people give it a name anyway. So it's about creating that sense of connection to the device, and if we're wanting to change behaviour, that's a really powerful driver for people to actually make a change if they start to anthropomorphise the device that they're interacting with. And ways to do that, I think this is a fantastic TED Talk, Robots with Soul by Guy Hoffman, where he talks about applying the principles of animation to make the inanimate feel more alive. And that may seem a little abstract until you see this home security device, maybe, that is actually, and I'm serious, it's a home security device, it's a video monitor and a motion sensor that has a great sense of character. And I think that if we look at the home security market, that idea of resource man, I think if you think of what typically is a product in that market, very much fits that. And this is very much taking a different approach to that. And I just love Urlo. Right? So, first steps. How many people have seen the fuzzy front end of design, this diagram before? Yeah, so are we. So a lot of this has been, there's no big reveal where we say all of this research has led to this amazing device, ta-da, here it is. We're not there. But I hope that it's kind of taking you through that little bit of a journey that we've been through and kind of examining that, looks at how we've defined a problem space and how we're trying to understand that, how we're using design techniques to properly understand that, to then come up with what that minimum viable product might look like. Trying to keep open the possibility that that product might look very different to where we started and what already exists in the market. One of the key things that we're doing is we're trying to understand from data what's meaningful and significant change in that kind of environment. I mentioned there's a lot of barriers to change in terms of, you may not see a lot of return on investment and things like that, but what does it actually look like if the Watson is going to glow red to make you feel like you shouldn't be doing something? What should it be telling you not to do, and how does that work in a real-time environment where the device is responding to your actions and you can respond to its actions in real time? There's not a lot of systems out there doing it, but there's also not a lot of data. Most of the systems that I've looked at, and I may be missing something, but most of them seem to have proprietary data stores. It's built into the Internet of Things business model that we own the data. We're not going to give it to, we'll give it to the individual homeowner, but we'll give it to you after the fact in the form of a spreadsheet. So if we wanted to do some experiments, and this is where I really like your model of the parallel development, the parallel diamonds. If we're wanting to do some experiments in product design, we need real-time data to be able to actually create those experiments. So the first thing that we need to do is start to collect that data. I'm running out of time. Joe's given me my cue. So I won't go into the details of why we couldn't use an existing off-the-shelf product. Suffice to say that it was a little bit difficult for us to do that. So we started to prototype and develop up our own using open source technology, the Arduino in particular, which Janine mentioned earlier, to develop our own simple energy monitor. This is one of the early prototypes that we started to refine over time. So different breadboards, you know, it's getting smaller and smaller, and to put that scale into perspective, that's a completed unit, just to give you an idea of the size, on the innards, and then the outwards look like that. So it's using off-the-shelf components, it's nothing kind of super fancy, to be able to collect that data and put it in a data store that we could actually then use and interrogate. We've put it into our first test installation, which is a big fancy way of saying my house. And we're actually debugging and testing the system, and it's been really, excuse the pun, illuminating. In a multitude of ways, the form factor has come into question, how we've been building it. It doesn't work. The idea was that they would be always on, and we realised that there's a whole bunch of PowerPoints that we turn on and off all the time, so we had to kind of adjust things for that. We found out that there's a lot of shared PowerPoints, so the original idea of actually having, well, we'll know that's the kettle. Well, it might be the kettle, it might be the toaster, it might be the blender, it might be the something, right? So those sorts of things start to become an issue. But ultimately, this isn't the end goal. So we're just trying to get data, but it's been really interesting to say that. The other thing is RGB LEDs are super, super bright, and they scare my dog. So when they flash, he's like, what's going on? What's going on? So when I use the word illuminating, it's quite literally. But it is giving us some answers to the questions of what does the heartbeat of the house look like, and how much does our coffee really cost us of a morning? The good news is it's not a lot, but it is something that we're starting to use. We're matching that with the qualitative research process as well, which at this point means an interview with my partner, but that was to test our interview guide, because we plan to roll this out into 3 different locations and actually do something a bit more serious with that. To be able to really understand the motivations for why people would do this, and really to understand those customer problems. What I don't have to present here is the list of about 16 assumptions that have come out of our lean canvas that we did, that we're trying to test in that research to try and understand exactly what the customer need is and things like that. So while I don't have a UVP at the moment, we've got some things in there that we're like, oh, we think it might be this, so can we test that? So we're doing that through the interviews as well. The early learnings from that process is that this is a graph that was taken of our house over the period. This is a 2-hour period. You may remember I said that graphs and charts don't communicate with anyone, but when you're dealing with 1,400 plus entries per unit a day, you need to have some kind of visualization to be able to do it. The other way, of course, you can do it if you're a data scientist and you've got statistics skills that I don't have, is probably to write some algorithms around that to surface some learnings. If anyone's a data scientist, I'd really appreciate having a chat, because I'd really love to be able to do that as well. But from a layperson like me, sorry, I just hit that, this has been really useful to get a sense of the pulse of the house, to understand what meaningful or significant change might look like. And it's proving challenging to think about what that actually means in terms of a product design, but it's an essential part of it. The other thing that I mentioned, the idea of open source hardware. How many people have heard of open source hardware before? Yep. Great. So for those that don't, it's a bit of a movement around how we can learn and share, in similar way to open source software, how we can build hardware devices or physical devices. It's an amazing thing. I'm very grateful to all the folks before me that have shared their knowledge. So when I say what I'm about to say, I mean it with the utmost respect. We're planning to pay it forward by making this particular design open source as well, writing up some instructables and things like that, because the flip side of the fact that it's really amazing, and I've been able to build it. Way back when I was a software developer, been doing a lot of UX more recently, but with that technical ability, I've been able to go from pretty much no knowledge to building a device that you're seeing here in the matter of a couple of weeks, which is I think is impressive for what the community has given us. The flip side of all of that, excuse the cheesy animation, is that It's been a lot of head banging against the wall as you try and pull together all the different bits of information, because no one's ever done quite what you're wanting to do. So you're having to pull that, and as a technical person, I know how often you have an assumption that, well, people would just know that, and you've got to do a lot of gap filling in order to be able to do it. So it's been quite frustrating in many respects. I was talking to Andrew, who's doing the video earlier, and he was relaying to me his very, very similar experience. He got to a point where, if hopefully I'm not mischaracterising what he said, but that is it me or is it the technology? And I've been in that moment 100 times on this journey so far, thinking through that. So it can be quite challenging, therefore it's not accessible to everyone, but I think that it is something that's worthwhile experimenting with, because you can get little inventor kits and starter kits to start thinking about what it's like to design for hardware and to develop for hardware. The constraints of the hardware mean that you really have to think outside of the box, and that can really be creative constraints or creative boundaries. You probably heard can be a real great source of inspiration once you get over the initial frustration of, I can't do that. Okay, so what can we invent around that? So it's a really great example, but I just wanted to use one example of how that affects your design decisions, because I'm not expecting you to understand the technology so much. If we look at some common devices, the iPhone SE at the top, the Raspberry Pi, which is in the middle. How many people have heard of Raspberry Pi? All right, so they're little microcomputers, about $35, but they run Linux, for example, or Android. The full operating system, you can do some pretty amazing stuff with it. And then down the bottom is the Arduino, which is the system that we use. Now, if we think about the amount of RAM that you have available, we're used to dealing in gigabytes. The iPhone SE, which most people consider to be a constrained environment for development, has got 2 gigabytes of RAM. And we can see the Arduino, it's actually less than 1 pixel. I had to use 1 pixel because otherwise you wouldn't see it. What that means in practice, though, is that just to do a request to a web server and get a response back can take up over half of the amount of memory that you've got. So you need to be really prudent in how you actually design and really start thinking about the ecosystem of devices that you need to be able to design for. So the ecosystem of devices is to keep the endpoints as kind of simple as possible and low resource as possible, to keep the cost down, to keep the computing power down, and then offload what you can to either the cloud, to a centralized device potentially. In our case, we're thinking about what might that look like. We're looking at another open source platform to be able to have as a central point that can do some of the heavy lifting across multiple different devices. The phone, we've actually implemented a phone interface for some of the configuration on this using an open source library that enabled us to be able to do that quickly. So even at this very early experimental stage, you're starting to think about those ecosystem of devices. The other thing is we put a deliberate design constraint, partly a cost, partly as a design exercise, because I thought it would be fun to think about this. I know I'm crazy, maybe geeky, but there's only 2 points of interaction with the device. One is a light that tells you what's going on, and the other one's a button that allows you to change stuff. And so the button is there for the Wi-Fi configuration tool to put it into a mode where I can use the phone to configure it. But the light was really interesting because I started to think of light as an animation technique. I'm used to having CSS animations or something to work with. Well, a blinking light is an animation. It's a form of animation, right? We've also got colour to work with in this particular design. We used an RGB LED light for that, which gives us some interesting things, you know, common things like red for error, things like that to give us status. But it was very interesting to start to think about that as an interaction design technique for somebody that's not used to working in hardware. I can tell you one thing though, when I first got my Jawbone, or a Fitbit, whatever you happen to have, it was really odd to me that they were doing certain things certain ways. I have a whole new appreciation for why those things, and imagine the computing power in one of these devices, probably even more constrained than what we're dealing with. The design decisions suddenly make a whole lot more sense, but I also have a huge amount of admiration for the designers that are coming up with these new interaction ideas. If you think around your home, a little exercise for tonight, I know it's just a little simple thing, have a look at the number of LED things in your house that provide you feedback and the patterns of interaction that you've been trained in with just that one interaction device, a light. And it's quite extraordinary when you start to look around the house and you start to see these things, and really interesting from a design perspective, from my perspective. So, where are we at? At the moment, we've now got what I would consider a platform for experimentation to do that parallel diamond, to start to, what does the device look like, or the tool set that might exist around that, because we're thinking about game design. So it might be that we just have a very basic feedback mechanism that feeds into a broader game that's a little lower fidelity, to start thinking about the points of interaction and to get that into home so that we can start to do those experiments and start to understand what that is. To me, that's really exciting, and it's the benefit of taking the time to go and build a system like this, even though it took a little bit longer than buying something off the shelf. If there's anyone that happens to be interested in this space and interested in experimenting with us, and being part of the process, we'd be happy to hear from you. And I've got 1 minute, so I think I'm on time. Yay!
We went from first Australians to the Pine 64, which is winging its way to you.
That's right.
So that's it. Unfortunately, we've got to go. I have time for one question, but we're heading to the pub, right?
Yes, yes.
So, is there any pressing question that you want to share with us now? Okay.
Just a little. So, have you generated some interest around from energy providers who are kind of keen to co-design with you and get involved in the program?
There's a certain hack coming up with Pollenizer that trying to get into. Haven't made any direct approaches at the moment. So one of our hypotheses is that the customer will be utility providers or other people that can aggregate the benefit of multiple savings. So that's one of our things. Therefore, if we're validating that particular problem, we need to be having those kinds of conversations. So we're kind of there. One of the hypotheses that falls on from that is twofold. Firstly, that the scale of the savings would be sufficient or significant enough for them to be interested. So that's one hypothesis. The other hypothesis is, what was that around? Lost it. But that they need to quantify the savings in order for them to be able to be interested in that as well. So there's legislation coming into play that means that energy companies will be looking to invest in savings rather than new infrastructure. So the idea is to have some answers to those questions in time for that legislation to come in. We're validating that in a base research, so doing third-party research, looking at the academic papers and things like that, to start to validate that. But I do want to have some conversations as well. The hypothesis that follows on from that is that we can develop a device that actually demonstrates savings. So if you're going to go to someone and say that we can generate savings sufficient enough for you to be interested in this product, well, how many savings? So in-home displays have demonstrated between a 5 and 15% energy consumption reduction, and so we want to be able to validate that we can actually produce a product that's going to deliver that using these techniques that either is that or bigger, so that we can go in with a quantified business case and unique value proposition for that particular market. I know that was a lot that I just said, but hopefully, yeah. So it is following all of those principles. The challenge for me, because I keep thinking about exactly what you've just said, and are we barking up wrong trees by prototyping and doing this kind of physical stuff before we go to market? Because I know that there are offers on the market that haven't done this level of work that are starting to get traction in terms of those markets. But there's a part of me that kind of thinks, no, this is the right direction. I don't know the right answer. I have chosen a particular path, and we'll see which one kind of works out, I suppose.
Ladies and gentlemen,